Hi guys and welcome back. In today's project we're going to be doing some web scraping, which means accessing a website, getting its contents, and then trying to understand it with Python so that we can extract some data. Websites all use HTML as the language of the text that we will be extracting. So we're going to understand what HTML is so that we can then use Python to understand what it means and we can extract some data with it. HTML is a markup language. Markup languages are used to annotate text in some way so that a computer can understand it. And HTML is a markup language because the annotations that it uses allow the computer to glean the structure of a web page and understand sort of what elements go inside what other elements and how the hierarchy of the website appears. Here's a simple web page's HTML. Now, this may not look terribly simple, but we're going to sort of deconstruct it over the next few slides as well and show you what it all means. You can see there's a lot of angled brackets or crocodile clips throughout this code, and at the very top we've got something that looks like a less than, exclamation point, doc type, HTML, greater than, and that is an HTML tag. This one particularly is a label that lets the computer know how to read the rest of the document. Essentially, it tells the computer this is an HTML document and you should read it as an HTML document. Then, for example, we've got the start of the HTML tag, and we're going to look at what tags are, but you can see that there's another crocodile clip, less than, HTML, and then there's some sort of lang equal en, and then a greater than again. At the very end, we've got the closing tag pair, which is essentially identical, but without the lang equal en, and also it has a forward slash at the beginning. You'll see throughout the document that there are other tags, for example this head tag, that doesn't have lang equal en, but it has a closing tag that is quite similar. We've got the forward slash head, and here it's the same but without the forward slash. So we're going to look a bit more into what tags are. This example is a bit simpler. We've got a div tag, that is the opening tag at the start and the closing tag at the very end with the forward slash in the front. Inside the div, we've got a p tag, that is for paragraph. And inside that, we've got some text. HTML uses this sort of structure where tags are inside of tags to define the structure of the page or the hierarchy of the page, which elements are inside which, and which elements are beside which. There's also HTML attributes. We can define values associated to names in each tag, as we've seen with the lang equal en just a moment ago. Different attributes have different meaning, and there's a lot of them that we can use, but class and ID are the two most popular ones, and they allow us to refer to specific tags a bit more easily when we use CSS. Here's, for example, some code that uses HTML attributes. The h1 tag inside the body tag has a class equal to header and an ID equal to page title. Notice that we've also got a closing h1 tag at the end of the line, and inside the tag we've got some text. So here we've got quite a lot of things going on, the two attributes class and ID, as well as the text inside the h1. H1, by the way, stands for header 1, so here this HTML code would be representing some sort of title on a web page. CSS is another language used to define the look and feel of HTML documents. So as we've learned, HTML is used to annotate text to tell the computer the structure of the page, which elements are inside which or beside which. CSS is used to define the styles, where color some things are going to be, or where they are going to be positioned inside our browser window. And to define which elements will receive which styles, we use CSS selectors. So here's some HTML code with some attributes. Some elements have some attributes, other elements don't have any attributes. We're just going to guide you through some common ways of selecting elements inside an HTML document using CSS selectors. And then we could use CSS to apply specific styles to those elements. For example, if we simply use the body CSS selector, i.e. we create the HTML document and then we create a CSS code, and inside CSS we type body, then we will be able to use CSS to apply styles to this element. In this case, CSS selector of body simply refers to the tag body, therefore the entire document in this case. We're not going to learn in this presentation how to apply styles to a tag. That's for another CSS lecture, but nonetheless, this is how we can select elements using CSS. When we come to web scraping, we're going to be using CSS selectors to find specific elements on a page, so that's why this is important. If we use, for example, H1, then we would be referring to the title in this case. So as you can see, if we simply type something out, like body or H1, CSS is going to select the tag or tags that have that name, body or H1 in this case. However, for example, if we wanted to refer to the tag with ID of page title, which is this H1, we could do hashtag page title. And that would tell CSS to go and find any tag, it doesn't have to be an H1, that has an ID of page title. If we go for the P tag, though, we would be selecting this element here, P with class of subtitle, as well as the one inside the main tag. Both of these are paragraph tags or P tags, therefore they would both be selected if we use that CSS selector. If we just go for dot subtitle though, that would give us any element on the page with a class of subtitle. ID attributes are normally unique on a page, but class attributes are normally not unique in a page, so therefore doing dot subtitle might give us multiple elements. Similarly, we can select a specific tag name that has a specific class name. For example, p.subtitle altogether gives us the same paragraph tag in this case, but it would give us any paragraph tag that has a class of subtitle. Note that there is no space between the p tag and the dot subtitle in this case, because spaces actually mean something else. Here, for example, we've got main space p, and what that does is it tells CSS to select the p tags that are inside a main tag. In this case, that's only the one shown there. Note that all of these tags are inside the body tag. So in every case in these selectors that we've shown, we could always do body space H1, for example, or body space hashtag page title, for example, and those would be totally valid. However, it is not necessary to define the whole hierarchy in a CSS selector. We just need enough so that we can select the elements we want. Alright, now that we know a little bit more about HTML and CSS selectors, let's go and do some web scraping. Alright, I'm here on REPL.it and we're going to start scraping and extracting information from HTML contents of web pages. But I figured that before doing that, we should try our hand at understanding, using Python of course, some HTML code so that we can then go and fetch this code from a website instead of having it in a string here. The process for fetching the HTML code of a website instead of just typing it out is a little bit different, but the outcome is the same. You end up with some HTML code that we need to then understand using Python. So by doing this, it's going to simplify our work a little bit, and then we can bring together the understanding of the HTML as well as the requesting of the HTML content from a website. So in order to understand HTML documents, we need something called BeautifulSoup. So what I'm going to do is I'm going to do from BS4 import BeautifulSoup. And this is what we're going to use. So this is the third-party library that we're going to use to understand HTML documents. The first thing to do here on REPL.it is, of course, to run the code and make sure that this installs and everything works. Notice that you want to install BeautifulSoup 4. That is the name of the library. The name of the library is not BS4. It is BeautifulSoup 4. So if you're installing this on PyCharm, we've got some information over linked in the description of this video with our blog post, and there we have some links for installation instructions as well. So now that we've got this, that means that we've got BeautifulSoup installed, and that is the library that is going to allow us to understand and go through HTML documents. The first thing to do when using BeautifulSoup is to load the document that we want to understand into this BeautifulSoup class. So we're going to do BeautifulSoup HTML doc, and we also have to say HTML.parser as a string, as that tells BeautifulSoup what type of document this is. BeautifulSoup can be used for understanding a few different types of document. HTML is just one of them, so that's why we have to tell it that. When we do this, BeautifulSoup is going to go through our HTML document and it's going to start laying it out and structuring it internally. And essentially what it's doing is it's constructing tag objects, that's tag with a capital T, for every HTML tag. So therefore, there is a lot of nested structure with these tag objects when we do this. We have the HTML tag. Inside it, we have the head tag and the body tag. Inside them, we have this title tag. And inside the body tag, we have this P tag. Inside this P tag, we have this B tag, and so on. So BeautifulSoup is going to create this structure, and we can navigate it. We can also use BeautifulSoup to search through the document. Whenever we search or go through the document, what we'll always end up working with are either tag objects or lists of tag objects. The first step when trying to parse an HTML document is for you to understand its structure yourself. So here, let's say that we want to get the names of the 3 sisters that are in this story. You can see that Elsie, Lazy, and Tilly are inside A tags. So we've got an A tag here, then we've got another A tag here, and we've got a third A tag there. And inside each tag is the name of one of the sisters. So let's go ahead and do that. We'll say sisters is equal to soup.select, and then inside a string, we will put the CSS selector that we want to use to find elements in this HTML document. So that is .sister, as that is going to find elements that have the sister class, as we have learned. So that's these 3. Now, because we have done select and that returns multiple documents, we are getting back a list of elements or a list of tag objects. We can do for sister in sisters, and then we can print, for example, sister.string. By printing out sister.string, that is going to give us the text contents of the tag. In this case, that's going to be each of the sisters' names. So let me open this up. I'll clear the content, and let's press run. And you can see we get back the 3 names. We're going to link the official BeautifulSoup documentation down below, so if you want to read some more about this, you can do that. But let's get started with the actual project. For this project, we're going to be scraping a site called books.toscrape.com. It's a purpose-built site for learning how to scrape real websites. The brief for this project is to scrape the front page of the site and grab some data for every book on that page. For each book, let's grab the title, the star rating, and the price. And then we're going to write all of that into a new CSV file. Before we do any of that, we need to get a hold of the actual HTML document, the contents of the site. And to do that, we're giving you this code. We're using another third-party library called requests. And using requests, we just do requests.get, put in the URL of the website that we want to scrape, and then we do .content. And at the end, what we get in our data variable is the HTML of the site. We're not going to go into a lot of detail on the requests library, but this is what you can use to get the content of any site. Note that I just said any site. That's not necessarily true. It depends on the website. Some websites are going to work like this and some are not. We'll also leave a blog post down, linked in the description of this video, that tells you when this works and when it doesn't. But for this site, it works. Now that we've got that, the next step is, of course, to do from BS4 import BeautifulSoup. And then we're going to load the data using BeautifulSoup. So we'll do BeautifulSoup data html.parser. And then we're going to do print soup.prettify. And that is going to display the contents of the site here for us to see. So as you can see, there's a lot of stuff in here. But we're going to go to the top and see what we can find. As you can see, this is too long, and when this happens, that means that the elements you're trying to view are too many for displaying here on REPL-IT, so our best bet is to go to the actual website and inspect it to look at the HTML documents. So here we have the different books on this site, and we can always right-click and press inspect, at least on Chrome. If you don't have Google Chrome or you're not using Google Chrome, do make sure to find this on your browser of choice. What we get here is the full contents of this site. Granted, these are a bit small, but you know, these are all the contents. And one of the benefits of using a browser in order to do this is that at any point, you can, for example, right-click on this image and click inspect, and then this brings you to the actual image code in here, and you can see as you go through the different parts being highlighted. Those are the tags themselves being highlighted, or the result of displaying those tags by the browser. Each of the books is stored as part of an OL tag, an ordered list. And each book is an LI element. You can see this because if we collapse this LI element, and then we go through the different LI elements here, they are each book. So we can see that each li class is one book. Therefore, if we want to find information about a specific book, all we have to do is go into the li tag, and then inside the article, then there's a div, and inside there we've got, for example, the image container. Here we've got the p class, which is the star rating. Here we've got an h3, which is the title of the book. And here we've got another div, which contains the price. Spend a little bit of time looking through this HTML so that you understand the structure of the site you're trying to scrape. We've got a bit of a breakdown of this in the blog post, which is linked down in the description below. We don't really have to worry about the image, because again, we're not going to do anything with that in this project, but we are interested in the star rating, the title, and the price. For the price specifically, what we're interested in is this p tag here. We're not really interested in the stock availability and so forth. You can see that the p tag for the price has a specific class name, and indeed if we were to go through the entire document, we would see that this class name is actually unique and only used for the price of each book. Therefore, by getting all the elements that are a p tag with this class, we will end up getting all of the prices for the books. The title, though, is a little trickier because, as you can see, it is an h3 tag, and inside it we've got an a tag, which is a link, and inside that we've got this text. Notice that the long title, such as A Light in the Attic, has got truncated because it's a bit too long to display on the site. What we have to do instead is access the title attribute of the tag that, as you can see, contains A Light in the Attic as a string. I'm thinking as I'm scanning this document that in order to access this A tag, I'm going to do the .productPod, which gives me one of these cards that contains a book. Then I'm going to go into h3, which seems to be the only h3 tag inside this article, and then I'm going to go into the a tag. Note that if you use that and you end up getting some other pieces of data around the site that you didn't expect, you just have to be more specific. For example, you might do OL with class of row, inside it an article with class of productPod, inside it an h3, and inside it an a tag. With that specificity, you're unlikely to be going into anywhere else. Finally, for the star rating, you can see we've got a p tag with a class of star-rating, and then we've got another class there separated by a space that says 3. This means that this book has 3 stars, and you can see that inside it, we've got 5 separate other tags, one for each star. Some of them, though, will be yellow, and some of them will be grey, and there's no real way to differentiate that from the HTML, so we're actually going to have to look at the text 3 in order to determine how many stars the book has. Alright, now that we've spent a little bit of time understanding the HTML structure of this document, which I recommend you do carefully in your own time, we can go back to REPL it and start coding this up. I'm going to start by putting my selectors into different variables. So I've decided that my price selector is going to be .priceColor, which is unique. The title selector is .productPod, inside it an h3, and inside it an a, and the rating selector is .starRating. Then what I'm going to do is I'm going to get these separate elements using soup.select. So we'll say prices equal soup.select with the price selector. Then we're going to do titles equal soup.select with the title selector. And finally, ratings equal soup.select with the rating selector. Note that BeautifulSoup is going to return these to us in the order in which they appear in the document. So the first book's price, title, and rating will always be the first element of the list of tags returned by soup.select. That means that using zip, we can now iterate through the 3 at a time. So we'll do for price, title, rating. In zip of prices, titles, and ratings, we can now print it out or put it into a CSV file. Remember that for the title, we need to access the actual title attribute of the tag. For the price, we just need to access the string contents of the tag. And for ratings, we have to do something that's a little bit more complicated. So for now, let's do print. And in here, we're going to put title, and then we'll access the title attribute of that tag. And the way we do that is as if it were a dictionary. And costs price.string, and that is going to give us the string contents of the price tag. All right, let me open this up, clear the contents, and run the code. And now you can see we get back the books in there. A Light in the Attic costs $51.77. That's pretty expensive. And no Python books around here. So there we have the title and the string. So the final piece of the puzzle is the rating. In order to convert the class name, which remember was 3 or 4 and so on, into an actual star rating, we're going to use a quick function. We're also going to define a dictionary so that we can map a given class name to something a bit more interesting. So we'll do rating mappings is going to be a dictionary mapping the strings 1, 2, 3, and so on to actual star icons. Notice that here we're using Unicode characters to represent the stars. If you can't do that, you may want to replace them by numbers or something like that. Then we can define a function that, given a tag, returns the rating by using our rating mapping. So we'll say get rating, given a tag, and we'll do for term rating in rating mappings.item. Then we'll do if the term is in the tags class. Remember, this is going to give us star-rating space 3, for example. We're going to see if term, which is the key, is in there. And in this case, 3 would be in there. Then we will simply return the rating associated with that class in our dictionary. In this case, this string containing 3 stars. So we can use that down here. Get rating of rating and see what comes out. So let me open this up, clear the contents, run the code. And now you can see that we get, for example, a light in the attic costs $51.77 and it has 3 stars. The next step is to actually save this into a CSV file. So let's do that. We'll first open the file. So we'll do with open of books.csv in writing mode as book file. And we'll put all of this inside it. Then instead of printing out, we'll simply do bookfile.write, and we'll write all of this. Remember to put a new line character at the end so that every line is indeed separated. Then instead of constructing a proper string here, we'll just separate these by a comma. Now, it is common to define the type of characters that we are writing to a file. This is called the encoding, so that when we save things into the file, they will get translated properly. Because we're using these special characters here, which are Unicode, we should specify that the file is encoded using Unicode. So the way we do that is encoding equal UTF-8. Now, if we run this, that's going to generate our file that we can then see here. And you can see that we've got a light in the attic, $51.77, and 3 stars. Of course, the 3 stars here might not be the best format for then retrieving and rereading. Again, you may wish to store a number there or something else that you find better. But for us, this looks pretty cool, so that's why we went with it. If you want to extend this project a little bit, try to scrape multiple pages. There are 50 pages of books on the site, and the pagination has a consistent URL format, so you can use requests.get to get each page. You can scrape the pages one at a time if you wanted to, and add that data to the CSV file. You might also want to try to scrape some of the detailed pages for the books to get more specific information for a specific book. But other than that, we're done. So thank you for joining me in this video. Thanks for watching. I hope you enjoyed it, and I'll see you next time.